Hello everybody, this is Code2J. Today I'm going to show you using hooks to query data from Postgres database, then upload it into the AWS S3 Bucket. Sounds exciting? Let's get started. I have a CSV file called orders, which contains artificial sales orders from March to June 2022. You can download it in the description below. It has 4 columns: order ID, date, product name, and quantity. We need to first import it into our Postgres database, then write a DAG to query data from it and upload it to our S3 bucket. Let's open dbeaver, connect to our Postgres database. If you don't know how to connect, check out this video. We are going to create a table called orders in the database test. Right-click test and set as the default database. Check the toolbar to make sure the database test is selected. Then create a table called orders using the statement create a table if not exists public.orders, and we define the 4 columns type correctly. In the end, we set order ID as the primary key. Execute it without error, refresh the tested database, and we can see the table orders have been created. Then we right-click table orders, select import data, choose import from CSV, and select our orders CSV file. And match the column names. In the final step, we click Proceed. We can see the import successful message. Let's query the first 100 rows for a double check. Great! We have set up our orders table properly. Next, let's create a DAG to query data from it. Let's go back to VS Code. Create a Python file called DAG with Postgres hook.py and open it. Let's first import the required packages. Then we create the default args. After that, we need to initialize the DAG with proper start day, schedule interval, and etc. Let's create a Python function called Postgres to S3, in which we will do 2 steps. Step 1 is to query the order data from the Postgres database, save it as a text file. Step 2 is uploading the text file into the S3 bucket. We need Python operator to run our Python function, so let's import the Python operator packages. To query data from Postgres database, we need the Postgres hook. Let's check the version of the installed Postgres package. Type command docker ps to find the container ID of the Airflow scheduler. Then use command docker exec-it container ID bash to enter the Airflow Docker container. Then run the command pip list pipe grep Postgres. We can see we have installed Postgres package version 1.0.1. Let's go to the Airflow documentation site. Search and click the PostgreSQL in the Providers Packages section. Select the version to match our local installation, which is 1.0.1. Then click the Python API. Here we see 2 sub-packages, hooks and operators. Let's click hooks. The documentation shows the hook is used to interact with Postgres database, and we can establish a connection to a Postgres database via the getConnection function. To initialize the Postgres hook, we need to provide the Postgres connection ID. Let's copy the whole class name, paste in our VS Code, and update it to from airflow.providers.postgres.hooks.postgres import Postgres hook. Next, let's go to our Python function to initialize the Postgres hook with the Postgres connection ID, which is Postgres localhost. We can get it from the admin connection page. Then we get the connection via the getConnection function from the hook. After that, we get the cursor from the connection. What we need to do is to ask the cursor to execute our SQL query statement. Let's say we want to get all the order data before May 1st, 2022. We just need to put the query select from orders where date is smaller and equals to 2022 May 1st into the cursor execution function. Then we write all the returned data into a text file using the CSV module. Let's first import CSV. Then we open a text file in write mode with name getOrders.txt in the folder dex. We get the CSV write first, then write the column name as the first row. After that, we write all the rest data in rows. In the end, we need to close the cursor and connection. Then we import the logging module and then write a log of save orders in text file getOrders.txt. We have the step 1 implemented. Let's create a task using the Postgres operator to run our Python function. We call it task1. Task ID is the Postgres to S3. Python callable is our function Postgres to S3. Let's go to the browser and refresh our Airflow web server. Oops, the error says we need to set the task ID. Let's check it in the VS Code. We mistakenly put DAG ID instead of task ID. Let's fix it and go to the browser to refresh again. Pick our newest DAG, start it, and wait for its execution results. Oops, it fails. Let's check the log. It says SQL syntax near order. Let's go back to the VS Code. We need to correct the table name from order to orders and put the date inside a pair of single quote. Let's rerun the DAG again. Great, we saw it is successful now. Let's open the log. We see it says the order file has been saved in getOrders.txt file. Let's also rerun the latest DAG run and check its log. Great, let's check our DAG folders in VS Code. We found only one getOrders.txt file which contains orders up to May 1st, 2022. The reason is that the second DAG run overrides the text file which was generated in the first one. Let's update our query to make sure we only get orders data during a specific DAG run's execution interval and save them with a dynamic text file name so that they will not be overwritten. To achieve this, we have to give the current and next execution date to our Python function. Let's open the Airflow documentation, select the installed Airflow version, which is 2.0.1. Search for the macro, then click it. Here, we found all the predefined macros. Let's find the node-current and next execution date. Copy them and paste directly as the parameters of our Python function, since Airflow will render those macros values during execution. Next, we need to update the query statement to have date conditions large and equal to the current execution date and smaller than the next execution date. Then we give the toMacros parameter as the query params. After that, we need to make our text file name dynamic with execution date as the suffix, and change the file name in the log. Let's save it and update our DAG version. Then go back to the browser to refresh the page. Select our newest DAG, start it, and wait for its execution. We saw 2 successful DAG runs on April 30th and May 1st. Let's check the latest DAG runs log. We saw the orders have been saved in text file with 200501 as suffix. Going back to VS Code, we saw 2 text files in our DAGs folder, each with the execution date as the suffix. Opening the text file, we saw it only contains the order data which is between current and next execution date. That's exactly what we want. Now, let's tackle step 2, which is uploading the ordered text file into the S3 bucket. Obviously, we need the S3 hook library to achieve this. Let's first check which version of the Amazon provider's package is installed. First, we make sure that we entered into the Airflow scheduler Docker container. Then we run command pip list pipe grep Amazon. We can see the version is 1.1.0. Let's go to the Airflow documentation site, select Amazon, and change the version to 1.1.0 on the top left. Then we click the Python API. Here, we look for hooks for S3 and click it. The doc says it is to interact with AWS S3. To initialize the S3 hook, we need to set the AWS connection ID. Let's copy the class name and go back to VS Code to import the S3 hook module. Then we create a S3 hook instance with the S3 connection ID we created, which can be found easily in the Airflow web server connection page. Then we need a function which can upload our local text file into the S3 bucket. Let's go back to the S3 hook documentation and search for the keyword load. Then we find the function load file, which does exactly what we need, loads a local file to S3. What we need is to indicate which file, which bucket and key to upload, and whether we replace the file once it already exists. Let's go back to VS Code to implement it. We need to call the load file function from the S3 hook instance. We set the file name as the file we named, which is DAG get orders with execution date as the suffix text file. Bucket name is Airflow. Key as the orders execution day.text. Basically, we upload all the orders text files in path orders and named by its execution date. And we set replace to true to replace the file if it already exists. Update the DAG version, save it, and go back to the browser to refresh. Pick the newest DAG and start it. Once it is executed, we see there are 3 successful DAG runs since the date is already May 4th. Let's check the latest runs log. Here we can see the order data has been saved as text file. Let's go back to VS Code. We can see there are 4 orders text files. Let's go to our Airflow bucket. We can see there are also 4 text files inside the path orders. We can download one of them and open it. Great! The file is exactly the same as the one in the VS Code project folder. It means we have achieved the second step successfully. This solution works perfect, except that I don't like to have a lot of text files saved in my DAGs folder. Is there any way to keep my workspace clean? Yes, Python provides the TemporaryFile package, which enables us to create files in a system temporary directory. Let's first import the NamedTemporaryFile module from the TemporaryFile package. Then, instead of creating the file in our DAGs folder, we use the NamedTemporaryFile to create the file object in write mode, and we can give the execution date as the file suffix. Before we uploading the file to S3, we need to flush the file object so that the text file is saved in disk. Our S3 load file function should be inside of the NamedTemporaryFile with statement, because the temporal file will be deleted once exiting the context manager. We can output the temporal file name by calling the name attribute of the file object. In the S3 load function, we just need to replace the file name to the temporary file name, which is f.name. Update the DAG version, save it. We go back to the browser. Let's refresh the page, pick the newest DAG. Before we start it, let's delete all the text files in our local DAGs folder and S3 bucket first. Then we start the DAG run and wait for its executions. We have seen the successful DAG run. Let's check one of the log. From the log, we can see the orders data was queried from the database and saved as a temporary file with the execution date as suffix, and then uploaded into our S3. Let's go back to VS Code. We can see our project folder is clean. There's no text file saved in our DAGs folder. Let's check our S3 bucket. Download one of them, open in a text editor. Here we can see each text file only contains all the orders records happens in the execution date. Great! That's it. You have learned how to use hooks to query data from Postgres database, upload file into S3 bucket, and keep your project folder clean by the NamedTemporaryFile. If you enjoy this video, please subscribe and click the like button. If you have any questions, feel free to write in the comment section. And last but not least, which Airflow topics do you want to see in the next video? Please comment below. I will talk to you in the next one. Bye bye.